Hello guys, welcome to my YouTube channel Anil Physics Academy. In today's lecture, we are going to discuss some important topics about the vectors. These topics are how to denote a vector, how to represent a vector in diagram, equal vectors, multiplication of a vector by real number and zero vectors. The first topic is how to denote a vector. Any vector is denoted by putting an arrow over the letters representing them. For example, V is a letter and if you put arrow over it, then it denotes a vector. F is a letter and if you put a arrow over it, then it denote a vector. AB are letters. If we put arrow over them, then they denote vector. CD are letters. If you put arrow over them, then they denote vectors. This method of denoting vector we generally use in our notebook. When we write anything about vectors, then we denote it by this method, putting arrow over the letters representing the vectors. In some books, the letters vectors are represented by bold face letter like this, V, like this V, F. These are letters written in bold face. So they denote vectors. But this method is not used in our notebook. In our notebook, we denote vectors by this method. Now, the question arises, how to denote magnitude of vectors? Magnitude of vectors are also called absolute value of vectors. Let us see this. Here magnitude of, for example, magnitude of V. There are two methods to denote magnitude of a vector. The first method is just write in them in mod. Mod V vector denote the magnitude of the vectors, or simply remove the arrow from the letter V. This denote the magnitude of vector V. Similarly, magnitude of F. This will be this or this. Now, how to denote magnitude of vector when it is written denoted by bold face in book? So when a vector is denoted in bold face in book, then their magnitude is denoted by light face letters. For example, magnitude of this vector V is equal to vector V or simply light face. Similarly, magnitude of F is equal to F or simply light face. So this is the method to denote a vector. Now we come to the second topic, how to represent vector in diagram. In diagram, a vector is represented by arrow. We know the arrow like this. Say this is a vector. Suppose this is a vector F. So this represents the vector in diagram. The front part of this arrow is called, head. The front part is called head and the rear part is called tail. See, the length of this arrow is proportional to the magnitude of the vector, and the direction of this head, is the direction of vector, because we know vector has both magnitude of and direction. So the length of arrow gives the is proportional to the magnitude of the vector, and the direction of head gives the direction of the vector. Suppose we want to draw vector which is same as equal to this vector. We want to draw a vector which is equal to this vector. How can we draw it? For drawing a vector which is equal to this vector f, we draw a line parallel to this arrow. Such in this way, and length of this line must be equal to this length of this line, and it must be parallel. So see, this arrow is parallel to this arrow, and they are both are parallel. So see, let it be f dash. So what we conclude? F is equal to f dash. So what are equal vectors? Equal vectors are the vectors which has same magnitude and same direction. See, if we shift this vector f, then after some time it will coincide with this vector. So what this shows? This shows that the parallel transformation of a vector does not bring any change in it. So if we shift this parallel the vector keeping its direction same in any place, then it will not bring any change in this vector. So parallel transformation of a vector does not bring any change in it. So what this indicates? It indicates that a vector has magnitude, a vector has direction, but a vector has not any location. Two vectors located at different places but having same magnitude and same direction are equal. So one thing we have to remember, that vector have magnitude, vector have direction, but vector have not any location. See, now if we draw a vector such that this, suppose length of this vector, this arrow is equal to length of these two arrows, but its direction is different because it is not parallel to these two vectors. So this, let this vector be f double dash. Then this vector is not equal to these two vectors because although it has magnitude same as these two vectors, its direction is different. So we can say that f is equal to f dash not equal to f double dash. Now we come to the fourth topic, multiplication of a vector by real number. So first of all, we see multiplication of a vector by a positive number. Let this be a vector A. Let this be a vector A, and we multiply it by a real number 2. Let it be 2A. So how we can draw vector 2A? Vector 2A is a vector having direction same as the vector A, but its magnitude is double that of vector A. So we can draw vector 2A as this way. This is 2A vector. Why this is 2A vector? Its direction is same as that of A. Why? Because both of them are parallel and its magnitude is double to that of A. As I said earlier, the magnitude is proportional of a vector is proportional to the length of the arrow. So magnitude of 2A is length of this 2A is double that of A. So magnitude of 2A is double that of A. Now if we want to draw 3A, then this it will be like this. Vector 3A, it will be like this. The direction of vector 3A is same as that of A and its magnitude is 3 times as that of A. Now let we are want to draw vector A by 2. Vector A by 2. Then how we can draw it? It will be like this. Means it has direction same of that of A, but its magnitude is half that of vector A. So this is this results we get when we multiply a vector by a positive number. Now what if we multiply a vector by a negative number? Suppose we draw, first of all, we multiply a by -1, then it will be minus a. So how can we draw vector -a? See, by if we multiply by vector by -1, then what does minus sign does? Minus sign reverses the direction of a vector. Means if this is vector A, then this is vector -a. Minus sign just reverses or make opposite the direction of a vector. Similarly, how can we draw -2a? -2a will be drawn like this. -2 is a vector having direction opposite to that of A and magnitude is double that of A. Similarly, if we draw -3a, how can we draw -3a? -3 a vector having direction opposite to that of A and magnitude 3 times that of A. Similarly, -12a. -half is a vector having direction opposite to that of A but magnitude half that of A. This is -half a. So these results we get if we multiply a vector by a negative number. What if we multiply a number, the vector by 0? Suppose let's erase it. If you multiply vector by A by 0, then what we get? We get a 0 vector. What is a 0 vector? 0 vector is a vector having 0 magnitude and indeterminate direction. It has not any fixed direction. Its direction is indeterminate. So now another property of 0 vectors are, if we add a 0 vector by a vector, then it comes to the vector. Or if we multiply 0 vector with a number, then also we get 0 vector. This is a 0 vector. So that's all for today, guys. Thank you very much.